Okay, we're going to continue with permutation. So yesterday we looked at fundamental counting and using factorial notation and so on to help with these calculations. But that's what we're going to do today. I'll call it 11.2. So we're going to look at just using permutations and using this formula to help us solve for permutations. So we'll figure out what that is in a minute. So remember, a permutation is an arrangement of items where order matters. The key thing is the order of the arrangement is important. So that'd be something like first, second, third in a race, order matters. Or lining people up in a row for a picture. The order is different depending on the arrangement. Choosing numbers for a lottery or something like that. Like if I was to tell you you had to match a 50-50 ticket number, obviously the order of the numbers are different, so you have to match it in exactly the right order. So yesterday we were looking at fundamental counting, and my advice is for easy questions, fundamental counting works well, but it also works probably the best for ones that have complicated restrictions. So that's things like saying, let's do the word Leduc, and if I say we want to arrange those 5 letters in Leduc, but we have to have a vowel at the front and a vowel at the back. So that means we got 2 choices for the first vowel for the first spot. Then the other vowel, only one left over, would go at the last. And then we got 3 consonants. So we'd have 3, 2, 1 in the middle for the consonants. And that would be our answer. So whenever you have your restrictions, it's usually best to use fundamental counting and make sure you solve with those restrictions first. Factorial notation, we looked at those, and these ones work best for repetitions. So if I gave you a word like Calgary, and we want to arrange all of the letters, we got 7 letters to choose from, so 7 factorial ways of putting them in order, but we have 2 A's, so we got to divide by those 2 repetitions. So repetitions work well for factorial or pathway questions. So remember, if I give you a pathway that has 4 blocks across, 3 blocks down, we're going to walk 7 blocks total, but we've got 4 repetitions of across and 3 repetitions of going downwards. So today what we're going to look at is doing the same kind of question, but we're going to use a formula, the permutation formula, to do this. And the types of questions where the formula works best is typically when you have partial groups. So let's go through the Leduc one again. So now I only want to choose 3 letters out of the 5 for Leduc. So for fundamental counting, we would have 5 choices for the first, then 4, then 3. So 5 times 4 times 3 would give us 60. Or we can see that 5 times 4 times 3 is almost 5 factorial, except we have to divide by 2 factorial. We don't want the 2 and the 1. So that would be another way of writing it, which would also give us the same answer. Now, the permutation notation is we can use 5p3, and that'll also give us 60. So on your calculator, go to math, scroll over to probability, and then the p notation I think is the 3rd one down. It has NPR, so all you have to do is type in 5, P3, and it'll give you your answer that way. So the formula itself, if we look at the last one, we said 5 times 4 times 3 times 2 times 1. That was our 5 letters in Leduc, and we only wanted the top 3, so we could write it as 5 factorial over 2 factorial. So that means if we have 5P3, that's the same thing as 5 over 2. So you can see in the bottom here, the n minus r, we just go 5 minus 3, and that gives us the 2. So basically what we're doing is we're saying we want to take the total numbers and divide by the ones we don't want. So if I gave you 10p6, that's going to be 10 factorial over 4 factorial. We want the 6 numbers, we don't want the 4. And then we could solve it from there using your calculator. So you could either do the factorial or the p, you'll get the same answer either way. Okay, here's the one that's a little bit harder. It's saying solve for n if np2 equals 110. So you could guess and check, or if it's multiple choice, you could match your ABCD to see which one would work. So you could try 8p2, see if that gives us the right answer, 9p2, 10p2, whatever the case may be. But we can also use this formula to help us out. We know the formula is n factorial on top, and then the bottom would be n minus 2 factorial. We know that's going to equal 110. So we can actually simplify this. We know that n factorial means n times n minus 1 times n minus 2 and so on. So that means on the top we'd have n and n minus 1. The n minus 2, n minus 3 would cancel with the bottom. So we just get n and n minus 1 equals 110. And then we can actually solve that. N squared minus n minus 110 equals 0. And then we can factor that, so we'd have n minus 11 and n plus 10 would be our two factors. And so our answers would be 10, negative 10, and positive 11. Doesn't make sense to have negative 10 items, so 11 should be our answer. So on your calculator, if you go 11p2, that should give you 110 for your solution. Okay, so permutations work really well, like I said, when you're doing partial groups. So in this case, if we want 3 letters out of the letters in Mexico, we got 6 different letters, so that'd be 6p3, and that's it. For USA, there's 3 letters. We want to rearrange all 3, so we could use 3p3. But we also know from our last topic, we have 3 letters. We want to arrange all 3. We could write that as 3 factorial. So that means 3p3 is the exact same thing. So 6p6 would be the same thing as 6 factorial. Right? We're taking all 6 people out of the 6 and trying to arrange them in a line. So that's the same thing as just saying arrange all 6 people. If I go 6p1, that means we're just choosing one person out of the 6. So that means there's only 6 different ways of doing it, because we'd have 6 choices for the first person, and then we don't want the rest. So it would be like 6 factorial over 5 factorial. Right? So that's why we just get just the 6. And 1p6, that means we want to take 6 people out of 1. That means no answer, right? We can't do that. So the front number has to be the bigger one, the total, and then the second number has to be the smaller one. So 6p1 works, but 1p6 doesn't work. And that's all.